Force, as we know it, is a push or a pull acting on an object. A force, when applied on a body, can bring an object into motion if it was stationary, or it can change the speed of an object if it is in motion, or it can seize the motion of the body. Considering if the force is applied on a rigid body, then it can cause a linear motion or a rotational motion in it. And if it is applied on a non-rigid body, then it may change the shape or size of the body, and also it can cause a motion in it. According to the Newton's second law of motion, force is defined as the rate of change of momentum. From that we got the equation F is equal to m times a. The derivation of it, F, the force, is equal to change in momentum divided by the time. The momentum, as we all remember, can be given by the product of mass and velocity. So change in the momentum can be written as momentum final minus momentum initial divided by the time, where v is the final velocity and u is the initial velocity of the object. So taking m common, we get mv minus u divided by t, and as we know, v minus u divided by t, that is change in velocity upon time, gives us the equation for acceleration. So F is equal to m times a. Now when a force acts on a stationary rigid body which is free to move, which is not pivoted at any point, then it can cause a linear moment in that object, as shown in the figure here. This is known as linear motion or translation motion. When a force is applied to a rigid body which is fixed at a certain point known as the pivot, then it causes a rotational motion in it, as shown in the figure here. When the force F is applied on a circular disc which is pivoted at the center, it causes a rotational motion around the pivot, as shown in the figure. Now from this rotational motion of an object, we come to a new term that is known as moment of a force, or also known as torque. Let us consider an irregularly shaped surface which is pivoted at a point, and let the point be called A, and let us say a force of F Newton is applied at this point. Let the magnitude of the force be F Newton. The line of action of force would be something like this. Let the perpendicular distance from the pivot to the line of action of force be this, and let this point be known as point B. Now this force applied on the object as it is pivoted at the point A will cause a rotational motion in this direction shown by the arrow. It will bring the object into rotation. This is the turning effect of the force applied. Now the factors affecting the turning effect of the body are: number one, the magnitude of the force applied. Higher the force is, more the rotation of the body. And second factor is the distance of the line of action of force from the axis of rotation, that is the pivot. In simple terms, the distance AB from the point pivot to this point, the line of action of force, the perpendicular distance between them. So these two factors affect the turning effect of the body. Now if you want to measure this, how can you get the numerical value of the moment of force or simply torque? Then there is a formula which is the force multiplied by the perpendicular distance of the force from the point A. In our case it is AB. So this formula will give you the magnitude of the moment of the force, that is also known as torque. If we talk about the unit of moment of force, it consists of the force, so Newton, and distance, so meter. The unit of torque will be Newton meter. The other unit which is also used for measuring the moment of force is, as it is force multiplied by the distance, it can also be taken as kgf, kilogram force, times meter. And if you want to equate, 1 kilogram force into meter is equal to 9.8 Newton meter, because 1 kilogram force is equal to approximately, we take the value as 10, 1 kilogram force is equal to 9.8 Newton. The smaller unit of force is 1 gram force into centimeter, and that equals to 989 centimeter. Now when the force is applied on an object which is pivoted, let us say a circular object which is pivoted at the center, let the point be called O. Now if the force is applied in this direction, then it will cause a rotation in this direction. This can be also called as anti-clockwise rotation of the object, or simply anti-clockwise moment. Now if the force is applied in the reverse direction, let the force be applied in this direction, then the rotation of the body will be in this way, then it will create a clockwise rotation or clockwise moment. We can make an equation: moment of force is equal to the force multiplied by the perpendicular distance between the pivot and the line of action of force. So we can say that moment of force is directly proportional to the amount of force. If the amount of force increases, then the moment also increases. If the amount of force decreases, the turning effect or the moment of the force also decreases. And similarly, the moment of force is also dependent. Moment of force is directly proportional to the perpendicular distance between the pivot and the line of action of force. If the distance increases, the moment or the turning effect also increases, and if the distance decreases, then moment also decreases. And if we want to compare from this, what is the relation between the force as M is equal to F into AB? If we want to compare the force and the distance between the pivot, the perpendicular distance between the pivot and the line of application of force, we can say that M on F equals to AB. If you take the moment as constant, we get 1 upon F equals to AB, or we can say that 1 upon F is proportional to AB. So from this we can say that the force and the perpendicular distance between the pivot and the line of application of force is inversely proportional. If the distance increases, then you have to apply lesser force, and if the distance decreases, then you have to apply more force. It can be understood from a common example. Suppose if we have a door which is hinged, let us say at this point. Now we apply force at the handle which is at the farthest distance from the hinges. Let us assume that we are applying force at this point. Let the point be point A. It is very near to the hinges, that is why we have to apply higher force. Now if we apply the force at the handle, that is point B, which is at the farthest distance possible from the hinges, we have to apply very little force. So let the hinges be called O and O dash. If the distance between the hinges is very less, then you have to apply more force. And if the distance between the hinges and the door, the handle of the door, is more, you have to apply less force, or the force required is very less. This can also be understood with an example of a steering wheel where the pivot is at the center. Now if you apply the force at the hinges, then it would be easier to rotate the steering. Similarly, if you apply the force near the pivot, holding the handle, the steering near the pivot, you would have to apply larger force. Similarly, a grinder has a handle. Grinder is something that is used to grind the grains. The handle of that grinder is provided at the boundary, whereas the pivot is at the center. So more the distance from the pivot, less the force is needed to apply. Similarly, you can also take an example of a spanner that is either used to loosen or tighten a nut. Suppose this is the nut and the spanner used is of long handle. Why do we provide such a long handle for a spanner? So that we have to apply less force. Now if just imagine that you are holding the spanner from this point. Suppose if you are holding the spanner at this point and you are trying to turn it to tight or loosen the nut, it will be very difficult. So it is not feasible. If you are holding the spanner from this point, then you have to apply less force to tighten or loosen this nut. So this is the basic idea about the turning effect of force, also known as torque or moment of force. We'll discuss about the couple and the moment of couple, kinds of equilibrium bodies in the next session. Thank you for watching.